Indian Ocean. This is not just an ocean. This is Earth's oldest living secret. There is a place on this planet where ancient trade winds have carved corridors through the water for thousands of years, where civilizations rose and fell along its shores, where beneath the surface lies a world of fire, silence, and life so strange it defies everything we thought we understood about existence. A place where the sea floor opens into rifts so deep that no human eye has ever witnessed what rests at the bottom, where currents older than memory still move with the same rhythm they did before our species existed. This is not legend. This is the Indian Ocean. Covering more than 70 million square kilometers, the Indian Ocean is the third largest body of water on Earth. It is surrounded on three sides by land, locked between Africa to the west, Asia to the north, and Australia to the east. It has no open boundary to the north, no cold polar escape. It is, in many ways, a trapped ocean, a closed world. And like all things confined, it has developed in ways that are entirely its own. From the shallow coral gardens of the Maldives to the volcanic ridges rising from its center, from the monsoon-driven surface to the lightless hadal zones far below, this is where Earth hides some of its most extraordinary secrets. But what lies beneath is far more than warm water and familiar coastlines. Hydrothermal cities on the ocean floor, migration corridors used by the largest animals alive, underwater mountain ranges stretching thousands of kilometers, ancient sediment layers preserving records of mass extinctions, and a climate engine so powerful that it controls the rainfall of 2 billion people. In this journey, you will discover the hidden geography of one of the least explored oceans on Earth, the currents that breathe like a living thing, the creatures that evolved in isolation, the geological forces still tearing the ocean floor apart, and the fragile balance between a world that has existed for 180 million years and the civilization that is now changing it faster than any force in its history. Because the Indian Ocean is not just a place we sail across. It is a place that built the world we live in. The shape of an ocean. There is no northern horizon in the Indian Ocean. Travel far enough north and you hit land. This single fact changes everything. Unlike the Pacific or Atlantic, the Indian Ocean cannot breathe from both poles. It is sealed at the top by the great landmass of Asia. And this confinement created something found nowhere else on Earth: the monsoon. A seasonal reversal of wind and current so complete, so total, that the entire surface of the ocean shifts direction twice a year. In summer, heat rising from the Asian continent pulls moisture-laden air northward from the ocean. Winds sweep across the surface, currents reverse. Rain falls on a scale that feeds billions. In winter, the cycle inverts. Cold air descends from the Himalayas. The winds turn. The currents shift again. The ocean breathes out. This rhythm is not weather. It is the ocean's own heartbeat. Beneath that surface, the geography is extraordinary. The Indian Ocean contains one of the longest mountain chains on the planet. The central Indian Ridge stretches for thousands of kilometers across the ocean floor, a place where tectonic plates are being pulled apart in real time. Magma rises through these cracks. New seafloor is being created. The ocean itself is growing wider, millimeter by millimeter, century by century. To the east, the Java Trench descends beyond 7,000 meters, a scar in the Earth's crust where the Indo-Australian plate is being dragged beneath the Eurasian plate. This is where pressure becomes absolute, where temperature flattens near freezing, where the weight of the ocean above becomes something that cannot be measured in human terms. And yet here too, life was found.
Scattered across this vast floor are thousands of seamounts, underwater mountains rising from the abyssal plain, some reaching within a few hundred meters of the surface. Each one is an island of life in the deep. Currents collide against their slopes and drive nutrients upward. In these places, the deep and the surface connect, and where they connect, the ocean comes alive. We have mapped less of the Indian Ocean floor than we have mapped the surface of Mars. Entire geological systems remain unknown. Entire ecosystems wait undiscovered. The Indian Ocean does not give itself away easily. The breath of 2 billion people. At first, the Indian Ocean surface looks calm. Vast stretches of blue, broken only by the slow rise and fall of swells. But this surface is a machine, one of the most powerful climate systems on Earth, and it has been running without pause for millions of years. It begins with heat. The Indian Ocean sits almost entirely within the tropics. It absorbs more solar radiation per square kilometer than any other ocean. That heat does not stay. It moves, rising into the atmosphere, driving winds, pulling moisture from the surface and carrying it thousands of kilometers inland. The southwest monsoon carries that moisture to South Asia and East Africa. When it arrives, rivers fill, crops grow, cities drink. When it fails, even slightly, famine becomes possible. This is not metaphor. This is the direct mechanism by which the Indian Ocean feeds or starves entire nations. But the monsoon is only the part of the story. The Indian Ocean dipole is a phenomenon less understood but equally powerful. Like El Niño in the Pacific, it describes a shift in the temperature balance of the ocean. When the western Indian Ocean warms and the eastern cools, rainfall increases across East Africa and floods strike southern Asia. When the pattern reverses, the consequences reverse with it. Droughts descend on one side while floods rise on the other. This system has always existed, but it is not stable. As ocean temperatures rise, the behavior of the dipole is changing. Events that once occurred once a decade are now happening more frequently. The monsoon is arriving later in some regions and earlier in others. Patterns that civilizations were built around are shifting in ways that no historical record can fully prepare us for. The Indian Ocean does not just influence the climate. For billions of people, it is the climate. The life below. Beneath the surface of the Indian Ocean, a different kind of world operates on its own terms entirely. It begins, as it always does, with light. In the upper 200 meters, sunlight still reaches. Phytoplankton drift in vast, invisible clouds, converting that light into the chemical foundation of all ocean life. They are so numerous that from space their blooms can be seen as shifting green and blue patterns across the ocean surface. And where they are, everything else follows. The Indian Ocean supports some of the largest tuna migrations on the planet. Yellowfin tuna move through these waters in schools numbering in the millions, following thermal boundaries, chasing the zones where cold, nutrient-rich water rises to the surface. They are among the fastest animals in the ocean. They do not stop. They cannot stop. Their biology requires constant motion. Whale sharks move through the same corridors. The largest fish alive, creatures reaching 12 meters in length, filtering thousands of liters of water each hour. They are filter feeders in a world of predators. Slow, enormous, ancient, they have existed largely unchanged for millions of years. And yet, even they are vulnerable. Deeper, where light begins to fail, the Indian Ocean reveals a different kind of life. Lanternfish rise at night in what scientists call the deep scattering layer, a biological formation so dense that early sonar operators mistook it for the ocean floor. Millions upon millions of small fish rising toward the surface in darkness, feeding, then descending again before dawn. This migration happens every single night across the entire ocean. It is the largest coordinated movement of living creatures on Earth, and most people have never heard of it. Below them, in the true deep, life operates on a different energy source entirely. At hydrothermal vents along the central Indian Ridge, bacteria draw energy not from the sun, but from hydrogen sulfide rising from the Earth's interior. Around these vents, communities of creatures exist in complete independence from the surface world. Tube worms meters in length, blind shrimp, pale crabs moving across rock that glows with heat. An entire ecosystem running on geothermal energy, a world that does not need the sun. These vent communities are believed to be among the oldest forms of life on Earth, and some scientists believe they may represent the origin point of all life, the place where chemistry first became biology, where the planet first became alive.
The cost of exploration. For centuries, the Indian Ocean was the center of the world's most important trade network. Arab, Indian, Chinese, and later European merchants crossed it in both directions, carried by the predictable winds of the monsoon. Spices, silk, cotton, and gold moved through these waters for thousands of years before the first European rounded the Cape of Good Hope. The ocean made the modern global economy possible. Today, the Indian Ocean carries 40% of the world's seaborne oil trade. Container ships move through the Strait of Hormuz and the Strait of Malacca in continuous streams. More cargo crosses this ocean than any other. And beneath those shipping lanes, below those tanker routes, the ocean continues to do what it has always done: feed the atmosphere, sustain the food chain, absorb the heat. But it is absorbing more heat than ever before. The Indian Ocean is warming faster than the global average. Coral reefs that survived ice ages and mass extinctions are bleaching in waters that have become too warm for them to survive. The reefs of the Maldives, of the Seychelles, of the Lakshadweep Islands are under stress that no previous generation of corals in those locations ever experienced. Dead zones are expanding, areas where oxygen concentrations have dropped so low that fish cannot survive. These zones grow as warming water holds less oxygen, and as nutrients from land runoff fuel algae blooms that consume what remains. And plastic. It enters from every coast, carried by rivers, blown from beaches, lost from ships. It accumulates in gyres, breaks into microparticles, enters the food chain at the level of plankton, and moves upwards from there, into the fish, into the birds, into the people who eat them. This is the ocean we have inherited, and it is the ocean we are changing.
The edge of what we know. Despite everything, despite the satellites and the submersibles and the decades of oceanographic research, the Indian Ocean remains largely unmapped, largely uncharted, largely unknown. When Malaysia Airlines Flight MH370 disappeared over the southern Indian Ocean in 2014, search teams discovered just how little we know about this part of the world. The seafloor in that region had never been properly surveyed. Ships spent months scanning depths that no instrument had ever reached. They found mountain ranges that did not appear on any chart, canyons of unknown scale, a seafloor geography that was, in every meaningful sense, a blank. They did not find the aircraft. The southern Indian Ocean is among the most remote regions on the planet. Storms cross it continuously. Swells can exceed 15 meters. It is cold and violent and empty in ways that are difficult to comprehend until you are standing on a ship, watching the horizon disappear beneath the next wave. And even here, the ocean has more to show us than we have been able to see.
New species are still being discovered in Indian Ocean waters every year. New geological formations are being identified. New current patterns are being observed that do not fit existing models. The ocean is not finished revealing itself. We are simply running out of time to pay attention. Because the Indian Ocean is not just a body of water that connects continents. It is a system that has sustained life on this planet for longer than our species has existed. It is a climate engine, a food source, a genetic library, and a geological archive. Everything that has ever lived or near it has left a record somewhere in its depths. The question is not what the Indian Ocean can still teach us. The question is whether we will protect it long enough to learn. Because the future of the Indian Ocean is not hidden in the deep. It is being written on the surface, right now, in the decisions being made above the waterline. And unlike the ocean itself, those decisions cannot wait.